Very good afternoon to everybody. I'm very happy to welcome every one of you for this faculty lecture series lecture today. And today we are going to have with us Professor J. Prakash of Mechanical Engineering Department. He is going to deliver his lecture on the topic 3D printing technology. And first of all, I'd like to welcome the director placement, Dr. Rajendran sir, and HOD ECE madam, HOD CSE Kumar sir, and all the faculty members who have joined. Welcome every one of you. And about this faculty lecture series, it's initiated by our beloved principal sir, going on very well. And of course, we are recording these lectures. It will be all will be collected and it will be posted in the link will be shared to all the faculty members either through our info KOT or from HRDCL's YouTube channel. And we can view that lectures later on also. That is one provision we are going to have. And it has been continued for past 3 this is third week we are doing this activity. And about this 3D printing technology, you all know this is the technology which is ruling now in almost all the areas. And almost in each and every field, not only in manufacturing or mechanical engineering related, in all the sectors, this 3D printing is playing a vital role. And today we are going to see about what is the 3D printing technology is about. And with us today, our Dr. J. Prakash, who is Assistant Professor in Mechanical Engineering Department, has completed his BE from ESB Engineering College, Karur, and later on is completed his MTech. And is doing his research in the area of robotics, and almost is in the verge of completing his PhD degree research work. And he is associated with our Knowledge Institute of Technology from 2012. He is working here for past 8. This is 9th year he is working here, and he is also taking care of our CAD CAM related training to the students, and especially our Center of Excellence, the Haritha TechSouth, that Center for Design and Technical Documentation, that Center of Excellence, he is taking care of it. And he is doing excellent things in placing our students in Haritha TechSouth company. So with this brief introduction, I once again welcome Professor J. Prakash for this lecture on 3D printing technology. Welcome you, Prakash.
Thank you, sir.
Over to you, Prakash.
Yes, sir. So, very good afternoon to all. So, I am very happy to be a part of this faculty lecture series. So, with this juncture, I thank our college management and our beloved principal sir, vice principal sir, and HOD sir, and all department HODs and faculty members for giving this lecture series opportunity. So the topic is 3D printing. So what are the contents involved? This today's talk is 3D printing, about 3D printing and history of 3D printers, and what are all the steps involved in 3D printing, and different types of 3D printing. So what are all the different types involved in 3D printing? So 3 major category we look into for today's session. So first one is a selective laser sintering method, and second one is fused deposition molding, and third one is stereolithography, and application advantage, disadvantages, and future. So these are all the content today we're going to see. So before entering to the topic, so do you have the best alternate of all those things? So first figure represents our human brain, and the second is artificial hand, and third one is a shoe, and fourth one is a artificial leg, and ear and bionic ear as well as nose, and heart. Next figure also heart, and pizza, and last one is a skull. So all those figure, the best alternative of all those figure is only thing is 3D printing. So that is the thing represents this slide. So we have a best alternative. Yes, it is a 3D printing technology. Yes. What is the difference between 3D printing as well as additive manufacturing? So before we going to that, we look into the manufacturing sector. So the process of converting raw material, components, and finished goods that meets the customer requirements and expectation. So it will be called as a manufacturing. So now we're going to see about what is mean by 3D printing. So the other name of 3D printing is additive manufacturing. So in manufacturing 3D printing, it consists of two major categories. So first one is subtractive manufacturing, and second one is additive manufacturing. So two manufacturing it is available. So in previous days and all, we are doing subtractive manufacturing. So in subtractive manufacturing, started from material and machining, final product, and waste of material. Starting from starting material, so we need to reduce the whole structure of material into designated part. So we need to reduce the maximum material in this segmentation. So loss of more number of wastage will happens in this subtractive material, but final product is a major outcome. So that will happen, not an issue, but more number of wastage will be happens due to this subtractive manufacturing. So, and another thing is additive manufacturing. So in additive manufacturing, we start from material, starting material. It is look like a filament. So, and this filament is connected with the nozzle, heating nozzle, and final outcome from the nozzle is liquid state of, semi-liquid state of component or product. So here, additive manufacturing, we are adding the product from initial stage to final end product. We are starting from bottom end to top end. So through this additive manufacturing, we are adding the material. So what we seen in previous topic is a subtractive manufacturing. In subtractive manufacturing, we are reducing the manufacturing process, and here we are adding the manufacturing process. So this additive manufacturing have a vital role in day-to-day life. So this is a final product, and wastage of that particular additive manufacturing is very, very minimum when comparing of subtractive manufacturing. So that is the specialty of additive manufacturing process. So so that's all about additive manufacturing. It is a 3D printing. Other name of additive manufacturing will be called as a 3D printing. And basics principle of additive manufacturing. The basic principle, we start from 3D model. So already you know about the 3D model. A 3D model we can easily generate through softwares, SolidWorks, Creo package, and then CATIA, NXCAD. Through this software, we can easily generate a 3D model. Okay. So, and we convert this 3D model into STL file, .stl file. So in STL file, we can easily discretization of the whole the object into a smaller pieces, that is able to do in this STL format. And next we go to slicing software. So why the slicing software is necessary is we going for 3D printing, we need to do a layer by layer process. So by layer process, we need to slice the particular component as an image, and we need to slice the particular component as a slicing pot, and it will move on to the, and it is a slice. We can easily slice the particular component, and the sliced pot image will transfer to 3D printer. So this 3D printer will generate the particular component by layer by layer. Okay, finally, the 3D object can easily generate through this 3D printing technology. So first one is a 3D modeling. We need to generate through basic mechanical softwares like Creo, SolidWorks and CATIA. And we need to convert a STL file, and we need to slicing the particular component. And this particular component slicing will move on to the 3D printer. So now the 3D printer will start the particular process, that is layer by layer, adding the particular component. It is done through this 3D printer. And finally, we can easily get the 3D object. So in every component, today we're going to see about three major technology in this presentation. For every presentation, these three parameter is a common one. So that is 3D model and the STL file conversion and slicing software. So these three part is very necessary for three types. And we see the history of 3D printers. In 1984, Charles Hull developed the first 3D printer and named as stereolithography. In 1990, fused deposition modeling and selective laser sintering were introduced. In 1999, first application of 3D printing in the field of medical, that is a human bladder, it was invented. And in 1993, MIT patented the another technology named as inkjet technology. In 2000, miniature of human kidney was developed through this 3D printing technology. And 2005, Z-Corp launched the first high definition color 3D printer. And 2009, the first usable prosthetic leg was generated through this 3D printing technology. And in this 3D printing technologies consist of three major categories. That is a modeling, and second one is a printing, and third one is a finishing of the particular component. These three major steps it is involved in 3D printing technology. So I already told about CAD modeling softwares. Through this CAD modeling, we can easily create the 3D modeling. So three-dimensional, you already know about it, is a X, Y, and Z axis. So through this SolidWorks, CATIA, Creo, and NXCAD, we can easily generate a 3D modeling. And we need to convert 3D modeling into a STL file, and it will move on to slicing of the particular component. And the slicing of the particular component, it will move on to the printing area. So from bottom to top approach, we are doing this printing technology. So in this printing technology, so slicing of the particular component we can easily generate in this printing. And finishing of the final product. So the desired object at a particular resolution, we can easily remove the extended material, and we can easily convert this particular material as a higher resolution of subtractive process. We can easily done through this finishing process. So these three steps, it is very important for 3D printing technology. And this figure shows the before resolution as well as after resolution of the particular component. And this is a before resolution, and then after resolution, we can easily convert the ordinary material into the high resolution material. We can easily generate those process in 3D printing technology. And three different methodology, that is in 3D printing, that is selective laser sintering method, fused deposition modeling, that is FDS, and stereolithography. So this major 3D printing technology we are using in our day-to-day life. The first one is a selective laser sintering method. Otherwise, it will be called as a SLS method. In selective laser sintering method, other name of that selective laser sintering method is powder technology. So we are using powder, and we are fusing the powder into a particular model. So this is the selective laser sintering diagram. So first one is a CO2 laser, and then beam expander and collimator and a galvanometer mirror. It is available, and three piston arrangement. It is available here. What is the use of three piston arrangement? So after conversion of your CAD modeling and STL file and the slicing of the particular component, it will move on to this CO2 laser as well as this piston pot. So we need to do the layer by layer process through this laser. So here three piston it is available. So the first piston will move upward of direction from the downward position. So then only the roller will generate the powder from the first piston, and it will move on to the second piston. So the beam, CO2 laser beam, will project the laser into that particular second piston, and third piston will the particular container full of powder. What is the powder? What is the material that is? It is a polymer, it is a nylon, and then polyamide and polycarbonate. So these are all the material as a powder in this selective laser sintering method. So for every layer by layer, the second piston will move from top to bottom approach. Top to bottom approach means if the one layer is completed from the CO2 laser, it will move from top to bottom approach. If one layer is completed, it will move down. So the same process will be repeated. And and here CO2 laser, the laser is passing through this beam collimator and galvanometer, and it will pass on to the second piston. Initially, the roller, what is the function of the roller is the roller will move from left hand side to right hand side through the second piston pot. So here the powder will convert as a solid pot. So through this CO2 laser heating methodology. So by layer, we can easily complete the entire process. So otherwise it will be called as a powder methodology. So this entire diagram here in this picture explains the 3D diagram, and the 3D diagram consists of 15 millimeter of diameter of the particular component, and height is 7 millimeter. The particular 15 millimeter of circle as well as height of 7 millimeter, it is drawn through this 3D modeling diagram, and it will move on to a slicing STL file, and it will move on to slicing the particular component, and it will move to laser source as well as the power bed. For every process, the powder will be projected through this power bed, through the roller. So layer by layer it will form, and the final outcome of the particular product is displayed here. And the right side figure shows the real selective laser sintering machine or printer. And now we see the selective laser sintering video. Then only we can easily understand what it is.
Metal laser sinter, also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials, such as stainless steel, cobalt chrome, and Inconel, to create strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised in the cartridge and recoated evenly on the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength, fine features, and overhanging surfaces. The completed part is then removed from the base plate and treated with an age hardening process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and polishing options available from service providers, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
Yes. Let's we see the second major part, that is a fused deposition molding. So in this fused deposition molding consists of filament pool, okay, so and filament, and here a gear controlled feeder, it is available here, and the final product is a nozzle. And now the filament spool, it is connected to this gear controlled movement feeder. So in this feeder, up and down of movement, it is controlled through this gear, and the filament is feeded into the nozzle. And here heater, before the nozzle, heater it is available. So heater heats the melt the filament. So here, what is the filament? What is the material of the particular filament? Is solid thermoplastics. It is nothing but ABS plastics and polycarbonate and polysulfone. So these are all the material we taken here as a filament. And here the heater it is available. From this heater, the filament will be heated here, and it will move on to the nozzle extruding part. Here, the layer by layer from this nozzle, we can easily create a particular pot. By based upon the STL file, the particular layer will be formed through this STL file and slicing the particular component. So this type of filament method, it will be called as a fused deposition of molding. So here we are heating the particular filament in a heater, and it will the filament will pass to nozzle. Through this nozzle, we can easily generate a particular material by layer. So this method, it will be called as a fused deposition molding. So this is the real fused deposition molding machine, so our printer. So this blue color, it will be called as a polycarbonate material. So we can easily generate this 3D model. And right side figure also we can easily generate through this fused deposition molding. And the cost of the particular fused deposition molding printer is 4,95,000. The size of that particular printer is 12 inches. And next part is a stereolithography. So now we can see about fused deposition modeling.
Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer on a build platform. Thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material on the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its support material. Raw FDM parts have visible layer lines. However, service providers such as Solid Concepts offer multiple finishing options to create smooth, even surface parts including hand sanding, assembly, and cosmetic paint. Since FDM parts are constructed with production-grade thermoplastics, including ABX, polycarbonate, and Ultem, they are both functional and durable. FDM is utilized in a number of industries, including aerospace, automotive, industrial, commercial, and medical.
So next method is stereolithography. So in stereolithography, it consists of vat. It contains a photopolymer resin and a flat form and the elevator. It is a resin surface and a laser beam. It is available here and laser source. And this platform will be carried through this elevator. So after completion of laser one layer, the elevator will move downward of direction. Then again the laser source will give the laser to this particular resin. Here in this stereolithography, the photopolymer resin will convert as a material. So that is the thing will going on here. So initially from your CAD diagram, we can easily generate a 3D model diagram and it will move on to the CAM part. In this CAM part, we discretization of the whole the object into smaller pieces and that is STL file format, and it will move on to slicing component. All the slices will be done. It will move on to the laser beam as well as the elevator to the platform, and both the things it will connected from your STL file. And here from the every laser source, if the laser is passing through this photopolymer resin, the resin is converted as a material in a one layer. After completion of the one layer, the laser source stops the laser and the elevator will move downward of direction at a one step. Again, the laser will move on to your photopolymer resin. So this process will be called as a stereolithography. So layer by layer, the elevator will move from top to bottom of it. That is, every layer, the elevator will move down. So layer by layer, it will form the major component of this resin is photopolymer. So here the resin will convert as a material here through this laser beam heat. So layer by layer, we can easily layer by layer, it can easily generated here. So the right side figure represents the stereolithography printer. The approximate price of this stereolithography printer is 3 lakhs. And this video we can see about stereolithography.
Shape the cube with equal 250mm size and standard quantity, or 125mm long and wide by 250mm tall in high resolution. The process begins with the creation of a 3D CAD model. This can be done in a variety of programs, including NX, SolidWorks, and many more. Once complete, the model is converted to an STL file and sent to the build station control software where support scaffolds are automatically added, and the part is cut into a series of slices around 3,000mm thickness. The model is now ready to be printed. The build platform is lowered into a vat of photocurable epoxy acrylate liquid resin, known as LP Gray, so that it rests 3,000mm below the surface. An ultraviolet laser is directed onto the resin using a series of computer-controlled mirrors. The laser causes the material to polymerize. The laser itself has 100 milliwatts of power available to it, and is a beam diameter of just 0.075 millimeters, meaning the solidification process is very accurate. The build platform then lowers a single layer thickness. Leveling blade sweeps across to ensure that the new level is recoated with a layer of liquid resin. Laser then selectively solidifies the next layer. This process of recoating scan is repeated layer by layer until the model is complete and the platform then rises up and out of the resin to allow the unsolidified to disintegrate away. Upon completion of the model, it must be removed from the machine and post-processing the model must be performed. First, any excess liquid and support structure are removed. The part is cleaned using isopropyl alcohol to remove any unfilled excess resin, and it is then cleaned using air and water to remove the solvent. The part is then placed in an ultraviolet oven in order to cure and fully solidify the part. Finally, the model can be sanded down using an ultrafine sand method to produce a smooth surface.
Yes. So now we can we see about application of 3D printing in medical field. We are using largely from 3D printing technology. And food industry, we can easily make a pizza without a human effort. That is possible only through this 3D printing technology. And games and entertainment, that is also possible. And defense and space application, we can easily use this 3D printing. And the industrial design and automotive and aviation industry also, we can easily generate the part in 3D printing technology. So industrial design for prototypes and all, we can easily done the prototypes through this 3D printer technology. So the one of the 3D printer technology is a Thrink3 lab. Through this printer, we can easily generate a prototype model. And in automotive and aviation industry, in 2010, Urbi, this is a first prototype car. It was generated through this 3D printing technology. And what you are seeing now, this entire part will we can easily generate through this 3D printing technology. So in automotive as well as aviation industry, we can generate maximum all parts in 3D printing technology. And in healthcare, in medical, now we can see about now we see about this video. So then only can easily know about how the 3D printing is effective for artificial arms for disabled peoples.
When we were younger, everyone was on our side. Then we grew a little and romanticized the time I saw flowers in your hair. It takes a boy to live, it takes a man to tend to his there. So then we grew a little, knew a lot, and now we demonstrated it to the cops and all the things we said. We were self-assured. It's a long road to wisdom, it's a short one being ignored. Be in my eyes, be in my heart, be in my eyes, be in my heart. So now I think that I love you back, and I hope it's not to make you so attractive and the way you move. I won't open my eyes. Make it compromise. So be in my eyes, be in my heart, be in my eyes, be in my heart.
Yes, for artificial arms and all, we can easily generate through this 3D printing technology. So this video is shown about 3D printing technology for artificial arms in medical industry. And in architecture, an artist can create models of the project. Artificial models also we can easily create. So those models we cannot make a model through 3D 3D modeling. So through 3D designing software. So for this one, we can easily use 3D scanner for creating this structure. So let's we see about what 3D scanner it is, and through 3D scanner we can easily create a 3D modeling, and we can easily slice the particular component. So this video shows about 3D scanning technology. Yes, in food preparation also, without human effort, we can easily make a pizza as well as chocolates through this 3D printing technology. Let's we see about making of pizza through 3D printing technology.
A number of companies are trying to revolutionize the food world using 3D printing technology. California-based BHEX hopes to change the way U.S. diners dig into one of their favorite culinary options, pizza. In 2012, very different from any other 3D printer. Prints dough, sauce, one key aspect of that of a heart and a rendering or drawing effective that the extruder follows. Pop it into the oven, bake it for a few minutes, out comes your pie.
Yes, in food technology as well as chocolates and candies, we can easily make through 3D printing technology. And bioprinting our teeth, and then bionic ears and bionic heart. Okay, so and bone grafts. So these are all the things we can easily generate through the 3D printing technology in medical field. And now we are using a lot of toys that is also we can easily make through this 3D printing technology. And animated characters, what we are seeing now, so in Sony Pictures and all, so all the animated pictures it is generated through this 3D printing technology. It is not assembled one, it is a full structure you can easily develop through this 3D printing technology. And defense also we can easily make the gun through this 3D printing technology. And the gun name is Liberator. It is in US. In out of this gun, the 15 components of this gun will made up of 3D printing technology. And officially, US is given permission for the peoples to use this Liberator for defense purpose. And this video represents the things you can make with 3D printers. Then only we can easily know about what are all the things we can easily done through the 3D printing technology. Yes, we see about advantages of 3D printing. So through this 3D printing technology, we can easily create models and prototype easily manner, and it is a clean process. Wastage is very low when comparing of a real-time manufacturing process. And complex shapes we can easily produce. No assemblage, we can easily done the full structure. We can easily build it through this 3D printing technology, and easy to use and reduce the design and complexity, and cheap and cheaper process than other process. And remote location, we can easily fabricate the particular object. That is the major advantage of 3D printing technology. And disadvantage is very slow, not a very slow. It is a slow, and component do not have a strength. So much strength when comparing of real components, we cannot comparing of this one. And cost of raw material is much higher, and 3D printers are expensive. And misuse of technology, it is happens in 3D printing of technology. And if you are doing 3D printers, so many human beings, certain jobs at risk. So due to this 3D printing technology, while you are using and you are competitor of others, so that is a disadvantage of human beings. And in future, it is very cheaper and better. So through this, we can easily generate organs for needy people for transplantation and all. So we can easily generate bionic ears and bladders and heart. We can easily generate through 3D printing technology. And these benefits of such a technology are endless. So with this quote, I end up my lecture. The future cannot be predicted, but it can be made. So thank you one and all for this lecture series. Thank you all.
Thank you very much, Prakash. Really wonderful presentation. Given the basics and how this 3D printing is used in various fields of engineering, and also in medicine. So the participants, you can ask your doubts. If you have any queries, you can please ask Prakash. He is ready to answer your queries.
Yes.
Please,
Very
madam.
nice presentation, Prakash. So many videos you have presented.
Thank you, ma'am.
Really much more information which we came to know today. And is one main question is, anybody can make use of this 3D technology? Otherwise, we need to get certain norms or standards.
No, ma'am. We can easily do if we know about a 3D 3D modeling component. ஒண்ணு என்னன்னாங்க மேடம், நம்ம 3D மாடலிங் தெரிஞ்சுன்னா 3D மாடலிங் மூலியமா நம்ம காம்பனண்ட்டை ஜென்ரேட் பண்ணிட்டு அதுக்கப்புறம் நம்ம பிரிண்டரை யூஸ் பண்ணி நம்ம பிரிண்ட் பண்ண முடியும் மேடம். நமக்கு 3D நாலேஜ், 3D பிரிண்டர், நம்ம 3D மாடல் மேக் பண்ற நாலேஜ் இல்ல, நமக்கு மெக்கானிக்கல் சாஃப்ட்வேர்ஸ் தெரியாதுங்கிற பட்சத்துல நம்ம காம்ப்ளெக்ஸ் காம்பனண்ட்டை நம்ம ஸ்கேன் பண்ணிட்டு அந்த ஸ்கேனரை நம்ம வந்து அசம்பிள் பண்ணிட்டு we can easily do the printing. ma'am.
That is my question is, if you know everything about it, அப்படின்னா யார் வேணாலும் அந்த டெக்னாலஜி யூஸ் பண்ணி என்ன வேணாலும் பண்ணலாம் இல்லையா?
Yes ma'am, அதனால தான் அத டிஸ்அட்வான்டேஜ்லயும் சேர்த்திருக்கேன் மேடம்.
இல்ல, disadvantage is there. Some policies or some rules, some என்ன சொல் law makers have to be needed இல்லையா? அப்ப எனக்கு தோணுது நான் பண்ணுவேன். You are showing in some videos there 3D fetal modeling.
Yes ma'am.
அந்த மாதிரி இப்ப யார் வேணாலும் பண்ணுவாங்க இல்லையா?
Yes ma'am, பண்ணலாம்.
It is not a right sign for technology to move இல்லையா?
எஸ் மேம், இது இவங்க தான் வாங்கணும் அப்படிங்கிற வந்து அது மாதிரி எதுவும் எனக்கு இன்னும் தெரியலைங்க மேடம். பட் கம்பல்சரி ஆஸ் ஆஃப் நவ் வந்து எல்லாருமே இதை பர்ச்சேஸ் பண்ணி யூஸ் பண்ற மாதிரி தான் இருக்குங்க மேடம். இப்ப அசம்பிள் பண்ணி கூட இந்த 3D பிரிண்டரை வந்து அந்த ஃபியூஸ்ட் டெபாசிஷன் மாடலிங் பிரிண்டரை வந்து இப்ப எல்லாருமே யூஸ் பண்ணிட்டு இருக்காங்க மேடம். We can easily
that's okay. For example, you are shown that pizza making, if a bakery person instead of sitting and doing a limited amount of pizza, he can make as much pizza, making use of this technology, it's good. Think about it, which you're showing the things, the features, the 3-dimensional printing which are shown. It is such a dangerous things, no? If people are using the technology, kandipa edadrukku, you kindly dig out the things, okay?
ஆமா மேடம், ஆக்சுவலா இண்டஸ்ட்ரியல்ஸ்ல வந்து வித் the permission they will go for a higher end printers, latest advanced technology. அதை வந்துட்டு யூஸ் பண்ணுவாங்க மேடம். பட் அது வந்துட்டு ஸ்பெசிபிக்கா யாரு மேனுஃபேக்சரர்ஸ் அவங்க கிட்ட இருந்து வாங்கி அதை கரெக்டா யூஸ் பண்ணுவாங்க. இந்த பிரகாஷ் சொன்ன மாதிரி அசம்பிள் பண்றதுலதான் நீங்க வந்துட்டு சொல்ற மாதிரியான இஷ்யூஸ் பாசிபிள். ஏன்னா அவங்க அசம்பிள் பண்றவங்க சப்போஸ் அந்த டெக்னாலஜி கொஞ்சம் ரொம்ப இன்டெப்தா தெரிஞ்சு அசம்பிள் பண்ண முடிஞ்சதுன்னா உங்களுக்கு ஹையர் எண்ட்ல வந்துட்டு அவ்வளோ ப்ரிசைஸா பண்றது கொஞ்சம் கஷ்டம். இண்டஸ்ட்ரியில யூஸ் பண்றது வந்து உங்களுக்கு கரெக்டான அந்த மேக் பண்றவங்க எக்ஸாக்டா ப்ரிசைஸா மேக் பண்ணி தரவங்க கிட்ட இருந்து வர்றதுல தான் உங்களுக்கு அந்த குவாலிட்டி ஆஃப் த ப்ராடக்ட் வில் பி தேர்.
Yes, yes.
நீங்க சொல்ற மாதிரியான சான்சஸ் இருக்கு, அதுல இஷ்யூஸ் இருக்கு.
Food items அது எல்லாமே வந்து இட்ஸ் a tolerable kind of things. 3D fetus making அது வந்துட்டு
அதெல்லாம் கொஞ்சம் ரிஸ்க் தான் மேடம். ஆக்சுவலா வந்து அதுக்கான என்ன ரூல்ஸ் அண்ட் ரெகுலேஷன்ஸ்
இல்ல
லாஸ் எல்லாம் எந்த மாதிரி தெரியல.
artificial arms, artificial leg, other organs, everything is okay. But you are making the fetus of 3 dimension அப்படிங்கிறது it's an interesting and much more fear factor of it. தான் இருக்கு. cloning மாதிரி தோணுது. I'm not sure about the
பிரகாஷ் வந்துட்டு ஹார்ட் வந்து செய்ய முடியும்னு சொல்லி சொல்றீங்க. பிரகாஷ் அது என்ன மெட்டீரியல்ல செய்வாங்க ஹார்ட்? அதை வந்துட்டு எப்படி உள்ள வைக்கிறது?
சார் பாலிமர் பேஸ்ட் ஆர் பாலிகார்பனேட் பேஸ்ட் வந்து ஹார்ட்ஸ் வந்து பண்ண முடியும்னு வந்து சொல்லிருக்காங்க சார். சோ இதெல்லாம் பாசிபிள்னு வந்து சொல்லிருக்காங்க சார்.
இப்ப ஆல்ரெடி 3D பிரிண்டட் ஹார்ட்ஸ் வந்துட்டு யூஸ் பண்ணி பார்த்திருக்காங்க.
எஸ் சார் வந்து யூஸ் பண்ணிருக்காங்க சார். அப்ராட்ல தான் சார் யூஸ் பண்ணிருக்காங்க. இன்னும் இங்க வந்து யூஸ் பண்ண மாதிரி தகவல் இருக்கு சார்.
Very nice topic. And as mechanical were chosen, the 3D printing and technology as an emerging area too. A lot of innovations are there and already existed, but how effective it is ங்கிறது எல்லாருமே பார்த்தா ரொம்ப நல்லா இருக்கும்னு நினைக்கிறேன். It's very good, interesting of it. Thank you
madam.
Thank you.
Questions from the participants? Dear participants, do you have any questions? Okay, fine. If there is no questions, we'll complete the session. Okay, thank you very much, Prakash, for your wonderful presentation about this 3D printing technology. And waste is reusable. There is a question. அந்த 3D அந்த waste வந்து reuse பண்ண முடியுமா?
Yes sir, வந்து பண்ண முடியுங்க சார். We can easily reuse the particular waste sir.
Okay. Fine. Actually anyhow அது வந்து பாலிமர் தான், வந்துட்டு அதை ஹீட் பண்ணி திரும்ப நம்ம reuse பண்ணி அதை
reuse பண்ணிக்கலாம் சார்.
reuse பண்ண முடியும்
சார்.
Any other questions? Okay, thank you. Thank you very much, Prakash. Thanks for your full presentation. And I like to thank, on behalf of HRDCell, I'd like to thank all the participants and the heads of the departments who have actively took part in this presentation, faculty lecture series. Thank every one of you for your participation. And in the coming future also, you will have very good topics like this through various faculty members of our department. Thanks to one and all. Thank you very much.
Thank you, sir.
Okay, Prakash. Thank you, Prakash.